This video is about syncing with latest server value every time device connects to Blynk. The following is an example. For example, a user owns a Wi-Fi connected dimmer light. The device goes offline. User sets the brightness of the light to 100% in the mobile app or on the web. When the device comes back online, it can request the latest value from the server and set brightness to 100. Below there are some sample commands such as Blynk.Syncall, Blynk.sync, but in this video we will use this command, Blynk.syncVirtual. You can see information related to this command here. This command updates individual virtual pin to the latest stored value on the server. When it's used, a corresponding Blynk write handler is called. At Arduino IDE, to start you prepare the code as here. The code of starter template sketch this time has an additional function Blynk connected. Because it is related to synchronization, the synchronization command and this function will be combined together. For testing, I need to add another switch widget. You click on Edit Dashboard. Drag another switch widget here. Name it Heater. You create a new data stream. Name the virtual pin data stream. Click on Create. Save. And save and apply. Here I have a schematic you can take a look at. And here is the circuit I assembled on the breadboards. Here you write some macros for the pins of the module. The fan button pin for pin 26. The heater button pin for pin 25. The fan LED pin for pin 33. And the heater LED pin for pin 27. Below, you write macros for the virtual pins of the data streams. The fan V pin for pin V0. The heater V pin for pin V2. Using synchronization, you need to write a Blynk write function for the corresponding pin. Initializing two variables to store the current state of the fan and heater. Assign the value received from Blynk to fan status. And assign the value received from Blynk to heater status. Set the mode for this pin to output. And the same for this pin. To continue, I need to install the button library. Why do I need this library? Here you can read that button is a tiny library to make reading buttons very simple. After installation, let's see its example. In this video, we just need to catch the button event being pressed. That's enough. First, we add the button library. Next, we initialize the button object. Here is the heater button. And here is the fan button. We pass the corresponding pin arguments to the constructor function. In the setup function, we call the begin method on the fan button object, similar to the heater button object. This method is placed in the loop function to catch the button press event. We need to catch the button press event for both buttons. After pressing the button, we reverse the status of the fan, similar to the heater. We update the fan status to Blynk. The heater is similar. the Blynk write fan vpin function, after receiving the status of the fan switch from Blynk, we update it to the hardware pin. In the Blynk write heater vpin function, it is similar. You copy the sync command here and paste it into the Blynk connected function. First, I will show you how to sync one virtual pin first. Now you upload the code to the board. After uploading, we check if it works well. First, turn them on from the hardware side. The status of the fan and heater is also updated to Blynk accordingly. Next, turn them off from the Blynk side. The status of the LEDs for the fan and heater on the hardware side is also turned off accordingly. Now we will check the synchronization. We need the hardware side to disconnect from Blynk. To do that, we can turn off the Wi-Fi transmitter that the hardware side is connected to. On the Blynk interface, you may have to wait a while to see the offline status. In fact, after you turn off the Wi-Fi transmitter, you can still see the online status of the device on the Blynk interface, but in fact, the device is offline after you turn off the Wi-Fi transmitter. After the device is offline, you change the status of the fan and heater switches so that it is different from the hardware side. Then you turn the Wi-Fi transmitter back on. After the device connects to Blynk, the LED representing the fan status is on, similar to the fan switch status on Blynk. This shows that we have successfully synchronized the value of the fan virtual pin. Now we will write code to synchronize the heater as well. You upload the code to the board. The status of these two switches is currently also the status of the two LEDs on the hardware side. When the device is offline, we turn on these two switches. When the device is online again, you can see that the status of both sides is synchronized. Here I do not include the temperature value. You may find this code confusing. The code about syncing one virtual pin. When the device connects to Blynk, this command will be executed. This command will ask Blynk to send the current value of the fan virtual pin on Blynk. When Blynk sends the value of this virtual pin to the hardware device, the content in this function will be executed.